Hello class, today we're going to talk about surface area of pyramids and cones. So you got a note guide and on the top of it it has this paragraph about lateral and surface area of pyramids. A pyramid is a solid with a polygon base. The lateral faces intersect at a common point known as the vertex. That's this thing right here. This is called the vertex. The altitude is the segment from the vertex that is perpendicular to the base. So you get this vertex. The altitude is this dotted line that goes straight up and down. Okay, that's the height. It's the same as the altitude. It's perpendicular to this base, so you see that right angle right there. For a regular pyramid means that the base is a regular polygon. When something is a regular polygon, that means that all the sides of the polygon are the same length, same size. So in this case, the base is a square. The base is a regular polygon and the altitude has its endpoint at the center of the base. So once again, this is the center of the base. All the lateral edges are congruent. All the lateral edges are congruent. I'm sorry, this is a lateral face, so all the lateral edges are congruent. This right here is a lateral edge. This right here is a lateral edge as it points to it. All of those are congruent. And all the lateral faces are congruent. Isosceles triangles. And this is only, once again, if this base of the figure is a regular polygon. The height in each of the lateral faces is called the slant height. It's very important that you understand the difference between slant height, which goes right down the center of the face, the lateral face, versus the regular height of the whole pyramid. The slant height is just for the lateral faces. The regular height is for the whole pyramid. Slant height will be noted with the lowercase l. We usually write it in cursive to distinguish it from a 1. Alright, so let's actually use this. So you've got an example, and it says using the picture above, using a regular square pyramid above, find the lateral area and the surface area if the length of a side of the base is 12 centimeters and the height is 8 centimeters. So it's the same picture as this thing. To the top of your paper, I'm just going to draw it myself. Okay, so something like that. I know it's not beautiful. But it says that the base edges are 12 centimeters. And it says the height is 8 centimeters. So that height is the one that's vertical, straight up and down. It's perpendicular to the base. Okay. In order for you to figure out the lateral area, you see up above in the little boxes, it tells you a formula for lateral area of a regular pyramid. It's 1/2 capital P times the lowercase l. If you remember, capital P means the perimeter of the base. So you got 1/2 the perimeter of the base times the slant height. Now here the perimeter of the base is going to be 12 on each side. You imagine this is a square, so back here in the back is 12. You got back here is also 12. So it's 12 plus 12 plus 12 plus 12. There's 4 12s. That'll give you a total of 48. Perimeter of the base comes from 4 12s, it's 48. Now you have the L, which is the slant height. That's the height down the middle of the lateral face. Okay? Actually, I'm going to undo that. I'm going to make that a different color just to emphasize it. So this thing right here. Slant height goes down the middle of the lateral face. It's perpendicular to the base. Slant height wasn't given to you. So you have to come up with some way to figure it out. And if we had time, I'd let you stare at this for a while. And I'm sure some of you might be able to figure out. If I draw this little line, maybe that would help you figure it out. So what kind of shape do you notice right here? Connecting the height of the pyramid, this little line right here on the base, and the slant height. Well, hopefully you notice that this is a right triangle. You've got 8. You're trying to figure out this red slant height right there. The L, that's what you want to know. This little blue line is not told to you, but maybe you can figure it out. It's actually supposed to be, since this is supposed to be the center of the base, and you have 12 along the edge. I didn't draw this very well, but from here to here is 12. This is supposed to be in the center, which means that this base right here is 6. Okay, so you've got a right triangle. You've got the sizes for 2 legs. That means you can use Pythagorean theorem. You're trying to figure out the hypotenuse. So you got a 6 squared plus an 8 squared equals the hypotenuse squared. The hypotenuse is L in this case. So you got 36, 64. You're trying to figure out L squared. Do a little math. You get 100 equals L squared. And I think most of you could figure out that L is going to equal 10 once you do the square root. So the slant height here is actually 10. We can put it in place of here. 10. Perimeter of the base is 48. Slant height is 10. You can now figure out the lateral area. 1/2 times 48 times 10. Multiply all those numbers together. You'll end up with 240. The units for this is centimeters. Area is in centimeters squared. So lateral area 240 centimeters squared. Okay, next comes the surface area. So surface area, just like it was on the prisms that we did, is going to be equal to the lateral area plus the base. Base is, on prisms, it's only one base. On a pyramid, so you got the lateral is 240. 240. You need to figure out the area of the base. In this case, the base is a square. The area of the base is a square is base times height for that square in particular. Its base is 12 and its height is 12, so it's 12 times 12. It's 12 squared. Okay, that's where the term squared comes from. So that's 144 for the area of that square. You add that to the 240, the lateral area, so you add those two numbers together, and if I did my math right, it's 384 centimeters squared. This is the surface area. Okay? So the only difference is you got one base on a pyramid, you have two bases on a prism. Okay, we're going to move on. So towards the bottom of the front of your note guide, you have more examples. You should have a picture that looks something like this. We're going to try another one. The same idea. Lateral is 1/2 capital P, perimeter of the base, times L, L slant height. Okay, in this case you got 1/2 the perimeter of the base. Well, it's told to, if you look at this carefully, you see that this is a pentagon. There's 5 sides. Okay, you know one of the base edges is right here, 8.7. Because this is a regular pentagon, that means that all of these base edges is 8.7. This one back here, 8.7. This one back there. So there are 5 8.7s. So you can do a little bit of basic math, add 8.7 5 times, or do 8.7 times 5. It's a little bit faster. You get 43.5. Okay. So the perimeter is 43.5. Perimeter of the base is 43.5. Now we need to figure out slant height. Slant height goes from the vertex down to the center of one of those lateral faces. So this is your slant height. And if you look at it very closely, it's kind of hard to tell with all these numbers and lines, but the slant height is 15. This is the slant height, L, lowercase l. So you're going to times that by 15. Okay, so multiply all of this stuff together. 1/2, you can use 0.5 if you want, times 43, times 43, times 15, and it looks like it's 322.25. Well, I just double checked my math, and I think I might have punched in something wrong, so I'm going to do it again. 0.5 times 43.5 times 15. 326.25. 326.25. The units are in inches. We're talking about lateral area, which is inches squared. So 326.25 is your lateral area. Now we're going to do surface area. Surface area is a little bit harder in this case. Still lateral, all the sides, plus the base, all the surfaces. You know the lateral is 326.25, what we just calculated up here. Now you got to find the area of a base. The area of a pentagon. Now here's the problem. I never told you the area of a pentagon or how you figure it out. So we're going to discuss that real quick. Okay, so I'm going to create a little space here. The area of a pentagon. So let's draw yourself. I'm going to draw a little picture of a pentagon. Actually, I'm going to come over here to this next picture. So there's the area of a pentagon. There's a pentagon for you. If you look closely, you'll see this from the center to the middle of one of the edges is 6 inches. This thing's pointing to 6 inches. From the center of the pentagon to the middle of one of the edges. So from the center to the middle of one of the edges. This is called an apothem. Similar to the radius on a circle. It's called an apothem. We actually skipped this chapter earlier, and I'm bringing it up now because you're going to need to use it a few times. And it says that that number from the center to the edge, the middle of the edge, is is 6 inches. So that's 6. Now how can we use this information, plus the fact that we know the base is 8.7, as it tells us in this picture. The base is 8.7. I'm sorry, the base edge is 8.7. To figure out the area of the whole thing. Well, once again, if we had enough time, we could stare at this for a long time and probably figure it out. But I'm just going to go ahead and tell you, you're going to break it up into shapes that you know. Okay, you could try lots of different shapes, but the easiest shapes are going to be a triangle. All of them branching out from the center, you draw a triangle. How many triangles do you see? Well, hopefully you see 5 triangles. 5 big triangles. 1, 2, 3, 4, 5 triangles. Now, in order for you to find the area of a triangle, maybe you remember the area of a triangle is base times height divided by 2. Well, we've got the base of this triangle is 8.7. We've got the height of the triangle is 6. And you're going to divide by 2. Don't forget to divide by 2. I see lots of mistakes coming from divide by 2. So you do your math there. Base times height, divide by 2. And you should end up with 26.1. Okay. These units were inches. So 26.1 inches squared for the area of this triangle. I'm doing green. This triangle right there. Okay. How many triangles are there? Well, there's 5 of them. So we're going to times that by 5. And that will give us an answer of 130.5. You can do the math and double check me. Pretty sure I did it right. Okay. So the area for the whole pentagon, write that down, pentagon is 130.5. So if we go back to surface area once again is the lateral plus the base. Lateral is 326.25. The base that we just calculated on the screen was 130.5. You add up these two numbers, and I believe you'll get 456.75. This is area in inches, so it's inches squared for your surface area. Okay, this includes all the sides, lateral, plus the base. Okay, now you have a question in your assignment that has a regular, I think it's a regular hexagon, it might be a regular pentagon, but what if this apothem was not given to you? It's going to be a little bit more challenging, so I'm going to give you a brief idea of what you're going to do and see if you guys can figure it out. Once again, you'll still break it up into triangles, okay, but what if you might just write this down somewhere extra, maybe on an extra piece of paper somewhere. We're just trying to take note of how this happens. What if you didn't know the height of this triangle? What if I just told you the base edge is 10? That's the only information you had. You could still find the area of this figure. Might be a little bit challenging, but this can be done. Now, if you imagine the distance around, if you drew like from here all the way around is how many degrees? Hopefully you're thinking 360 degrees. Now if I cut that up so I know how many degrees it's in each angle, this angle, and this angle, and this angle, this one, and this one, I cut up into 5 equal pieces. So I'm going to take 360 and divide it by 5. Okay, 360 divided by 5, 72 degrees. So each angle is 72 degrees. Okay, so this is 72, this is 72, this is 72, and so forth. Okay. Now, let me zoom in a touch. This is 72 for the whole thing. That still doesn't help me figure out the height. But if you look closely, you'll recognize that this is a right triangle right here. Right here is a right triangle. Okay. Now, I told you this base was 10. So if I cut this in half, this meets right in the middle. Now this is 5 and this is 5. You split this angle, bisect that angle, if you remember that word. This is 36 degrees right here. So now it breaks down into a right triangle with 36-degree angle right here. You got 5 for this thing. And maybe some of you are starting to make connections about how you're going to be able to figure out this height right there. Okay, hopefully you're thinking sine, cosine, tangent, SOHCAHTOA stuff. SOHCAHTOA. Okay, so you ask yourself, is this opposite, adjacent, or hypotenuse? Well, this one's going to end up being adjacent. Is this opposite, adjacent, hypotenuse? This is going to be opposite, so it ends up being tangent. And tangent's what it's always going to be. It's always going to be tangent no matter what shape we're doing, as long as it's a regular polygon. You put the angle next to tangent, 36 degrees. It's the opposite one, which is 5, or the adjacent side, which is x. Do a little cross multiplication. You'll come up with x tangent 36 equals, and you cross multiply this way, 5 times 1, 5. Maybe you remember that you're supposed to divide by tangent 36. Okay. And so you can do your math here. 5 divided by tangent 36, you'll get some kind of decimal. Let's see. I have a tangent on here. There's a tangent. So 5 divided by, that didn't do it. Give me a second, I'm going to punch in a calculator. I'm going to pause this. Alright, so once I punch that in, you should have 7.14, you get a whole bunch of other decimals. So let's use just a few of them. 7.1407. Since we're still in the middle of the problem, we're going to use several decimal places. 7.1407. Okay, so that is the height of this triangle. Okay, so now to find the area of a triangle is base times height divided by 2. So the base, let's go with this whole triangle, this whole thing right here. The base is 10. How many times about the height that I just discovered? 7.1407. I'm going to divide that by 2. You punch that into your calculator and see what you get. I believe you're going to get 35.7. I'm sorry, 35.704 if I round, something like that. So this is your area of that triangle, this blue shaded triangle right there. Okay, but how many triangles are there? Okay. How many triangles are there? 1, 2, 3, 4, 5 triangles. So you're going to take this area for the triangle and you're going to times it by the area of all 5 of them to get the area of the pentagon. So area for pentagon. Sorry, I got a little problem with my mouse there. Okay, so the pentagon equals 35.704 times the 5 triangles. Okay. And I've got 178.5. 178.5. Okay. Only reason I'm spending time on this is because there is a question like this on your assignment. So it looks pretty tough, but I want you to be able to figure it. Basically, split it up so you can tell how many degrees each triangle has. You're going to bisect that angle so that you can figure out how many degrees this is. You're going to end up using tangent and do some calculations to figure out the height. I'm sure you can do this. I'm confident. Just go ahead and give it a try. I can't remember exactly what number it is, but you'll know it when you come across it. There's one more example I want to go over. It's with a cone. A cone is basically going to be the same idea as it was with the other pyramids. 1/2 capital P times L. If you look closely at the notes, it says something like pi RL, I believe. And these are going to be the same thing no matter what. So I'll go through both of them. But 1/2 the perimeter of the base. In this case, the base is a circle. And if you remember, we call perimeter of a circle, we call it circumference. The formula for circumference is pi d. Remember the song? I should have the sub play the song for you. But you remember the song? And if you need circumference, you just use pi d. The slant height is this thing right here. Slant height. Unfortunately, that's not given to you. But you might notice that this is a right triangle. So this is 9, this is 12. And you can do some calculations to figure out L. 12 squared plus 9 squared. It's terrible. And that will equal L squared. Okay, 144, 81. You get 225. Square root of that is going to be 15. So this is 15. Okay. If you were over here using this one, the one that was given to you in the note guide, pi times the radius of 9. Sorry about that. And the slant height is 15. So you'll multiply this. Pi times diameter in this case is 18. So you got 1/2 pi times 18 times 15. Now maybe you can see how these two things are going to be the same idea. 1/2 of 18 is 9. And so that's where you're going to end up with the same stuff no matter which formula you use. I like to remember just this one, so it's one less formula you have to memorize instead of remembering a whole different one for a cone. It's still going to work the same way. As long as you know perimeter is the same as circumference, you know the formula for circumference, hopefully. 9 times 15 ends up being 135. That's 135 pi. Over here you get the same thing, 135 pi. You punch in 135 and times it by pi, you'll get 424.1. And so another long decimals, but this is the lateral area. Now the only difference between lateral and surface area is that surface area also includes the area of the base. So you have the lateral plus the base. You already know the lateral, 424.1. The area of the base means the area of a circle, pi times the radius squared. The radius in this case is 9. You square it, so you're going to get 81 pi. Okay, you can figure out what this is as a decimal, add it to 424.1. If you're going to upper level math like AAT, you could take the 135 pi and add it to the 81 pi and get a very exact answer. 135 plus 81, I believe that's 216, if I add it correctly. Okay, and yeah, you can convert to decimal. Or you can convert this to a decimal and add it to your 424.1. This as a decimal is 254 a couple decimal places 47. 254.47 added to your 424.1 for the lateral. That means that your surface area for a cone is 678.6. Sorry, I'm running out of space there. 678.6. Now, hopefully you're not just copying this down, but you're actually thinking about it. If you are copying it down, please go back and try to figure it out. 678.6 inches squared for the lateral. I'm sorry, for the surface area. And that's that. Sorry this video was so long, but hopefully you learned something. Alright, good luck on your assignment.